Okay, so in this question now, we're going to be providing solution to question 2 of the Living Set 2023 Higher Maths Paper 1. So question 2, I believe this is it. Just get the question itself over here. Alright, so this, as I said, this Living Set 2023 Maths Paper 1 Higher Level. Go back to question 2. Okay, so to question 2A, this is what we asked to work on. All right. So for time's sake, to speed up things, I already implemented this the solution. I'll just go over it and provide some explanations where it's necessary. So f of x is equal to x squared plus bx plus c. And where the limits are 3, coefficient of x is 3, and then -1 for y. Okay, so I have a little explanation here. So the coordinates b and c can be plugged to create an equation. So of course, because we have 3 for x and -1 for c, for y. And then the second step is then at the minimum, then we because at the minimum there we know the slope at the minimum level there, it would be 0. So when we say the slope, we're talking about the derivative, that is dx over dy over dx. So at the minimum there, the slope will be 0. That's the understanding there. When it gets to the limit, the slope will be 0. It won't have any slope anymore because that's the minimum level. Okay, so those are the things we know. So and if f of x is equal to x squared plus bx plus c, and then f of x, because f of x is like y, and that we're given the value to be 1 here, and this coordinate here 1. So we plug in 1 here, that is -1, sorry. We plug in -1 here, and then in the place of f of x, we're going to have -1 is equal to 3x, because x is 3. So 3 x squared plus xb, which is bx, which is 3b plus c. And then that gives us 3 squared is 9. Plus 3b plus c. So we have an equation here. We can express that in terms of c, but we can leave that for now as it is, and then we continue. Then we now get the derivative, because remember we said at the point, at the limit, at the 0 point, the minimum point, there's no slope there. There's no slant. The line doesn't slant anymore, so there's no slope. There's no gradient. And to get the gradient of a line, it is the dy over dx, the derivative. That's the gradient of that line, of the tangent of that line at that point, which is 0. So the derivative of this f of x is 0. So dy by dx, which is represented here, which is equal to get our dy by dx, we use the power rule here. If we use the power rule here, we're going to have 2x in place instead of 3. No, this is not it. We are here. Sorry, we are here. So the power rule, we get 2x plus b. All right, 2x plus b for the dx by dy, or dy by dx. So our dy by dx here, 2x plus b. This must be equal to 0 because this is the gradient at that point. At that point, which is 0. So 0 is equal to 2x plus b. Okay. And then 0, if we equate that now, we're going to have x is equal to 3. Of course, we know that x is equal to 3 because it was given to us. Then we substitute x, 3 in x. So we have 2 times 3 plus b is equal to 0. That gives us b is equal to 6, -6, as you can see here. But then we know that we have an equation here, 3b plus c is equal to the -10. So that's what we're bringing down here from this equation here. We're bringing it back down here. 3b plus c is equal to -10. And we know that b is equal to -6. So we can plug that in to get our value of c. So when we plug that in now, we're going to have c is equal to -10, -3b. Yeah. So from this equation, we're going to have c is equal to -10. Take 3b over there. It becomes -3b. So c is equal to -10, -3b here. And then c is equal to -10, -3 into 6. It should be negative. negative 3 times negative 6 is going to give us 18. So negative 10 plus 18 is going to give us 8. So our C is equal to 8. And what else did we get? And our B is equal to negative 6. Is that what they asked us to find? Yes, they said we should look for B and C here. Okay, so B and C, we have C is equal to 8 and B is equal to negative 6. So those are the two values we asked you to do. Now we go to the next one now. Say find the value of the following limit. Okay, so all right, so if you look at here, if you look at, let's take one term at a time. Let's do, so here I'm dealing with the first term here, the n in this term here. Where am I? I think I should do this one, this first term here. Let's deal with this one. Let's see how it's behaving as n is increasing, as n is approaching infinity. Okay, so we're gonna have, if n is equal to 1, we're gonna have 1 over 1 plus 1, which is 2, so it's gonna be half. Okay, now what if n is equal to 2? We're gonna have 2 over 3. So 2 plus 1 is 3. That's gonna be 2/3. It's gonna be 2/3. Okay, 2/3 is greater than a half. So we are greater. It's increasing. So what if n is equal to 3? Let me just do it on the same spot. N is equal to 3. We're going to have 3 over 3 plus 1, which is going to give us 3 over 4, 3/4. So it's getting bigger instead. This 0.75, of course, if you remember the point signs. And what if n is equal to 4? And we're going to have 4 over 4 plus 1, which is going to give us 4 over 5. That's already like how much now? 4 over 5. That gives me 0.8. That gives me 0.8. Here we had 0.75. Here remember we went from 0.5, 0.66 something. That's 2/3. Then 0.75 gives you 0.75. So 0.5, 0.666 something, 0.75. Now we have 0.8. 0.8. We're going, we go to 0.5, 0.666 something when it was 2/3, and then we have 0.8. Let's add it again when n is equal to 5. What do we have here? We have 5 plus, here we're going to have 5 plus 1, which is going to be 5 over 6. So what does 5 over 6 give us? It's going to give us 0.883 something, it keeps going. Then we that's 0.8, 0.83. It keeps increasing. Now let's see, we have 6 here, and it's equal to 6. We're going to have 6 here, 6, and then we have 6 here, 6. So it's going to be 6 over 7. Over 7. So what is 6 over 7? 6 divided by 7. 8.5 is growing. So let's get 8.5 there. 0.85 growing, 8.5 growing small. Let's say we go up to 10. N is equal to 10. Let's just say 9. N is equal to 9. Let's say 9 here. That's gonna be 9 plus 1. That's gonna be 9 over 10. So what does 9 over 10 give us? 0.9. So we have no 0.9 here. Okay. Now what if it is 10? Of course, gonna be, so what n is equal to 10? We're gonna have 10 over 10 plus 1. 10 plus 1. That's gonna give us 10 over 11. Divide that and see. 10 over 11, that gives me 0.9 again. So it's got stuck here, 0.9. It got stuck here, so it's at 0.9. Then if we add again 11, well, we'll keep, so it seems it got stuck at 0.9 there. It doesn't add anymore. It's stuck at 0.9, so towards 1, because if you have to get the decimal, because if you keep adding now, the decimal place will just be adding 999, so it got stuck towards 1. That's what we're trying to say. So it doesn't increase anymore. It doesn't go beyond 1. It was increasing when n was 1 until it gets to when n was 10. It doesn't add anymore. It doesn't increase anymore. It doesn't go beyond 10. It's always going towards 1. So these numbers will be increasing just towards 1. So if we go to 12, let's just say 15. 15, we're going to have 15 over n. 15 plus 1, that's going to give us 16. So what's going to be 15 over 16? That's going to give us 0.93. See, 0.93. It doesn't matter how big it is. Let's say 100 over 101. So 100 over 101. That's gonna be 999. Okay, so that we got stuck there. So it's approaching, because this one is 0.9909. So it's bigger than this one, obviously, but it doesn't go. It doesn't matter how big that number is. It won't go beyond 0.999 or towards 1. So it's increasing bit by bit, getting towards 1. It doesn't go above 1. So that's what we're trying to say. It will never get above 1, because this one is always adding that small edge. Okay, so when n increases, this term is approaching 1. That's the behavior at this level here. Now let's take a look at this one. So the value here is 1. We have evaluated this one to 1. So let's take this one now. Let's look at this one, how it behaves. So we have n plus 1000 all over n. This, you can express this one as n over n plus 1000 over n, because that's how you got n plus 1000 over n. So they got this from adding two fractions like this, because when you add these two, the common denominator there is n. N divided by n is n. N times n is n divided by n is 1. 1 times n is n, plus n divided by n is 1. 1 times 1000 is 1000. So that's how you got n plus 1000 over n, as you see here. Okay, so you can tear it apart again as the original was, so that we evaluate each term in that case individually. So n divided by n is 1, because n divided by n is 1. Okay, this is going to be 1 plus 1000 over n. So let's see how this one behaves. All right, so if we won't have the time to go through that, but this is how it's going to behave. Let's say n is equal to 1. N is equal to 1. This term will become 1000 over 1, which is equal to 1000. Very big. Okay, now what is n is equal to when n becomes 1000? So this number, when n was 1, this number is, this term evaluates to 1000. But when n is equal to 1000 as well, this term evaluates to 1, because it becomes 1000 over 1000. This is equals to 1. Okay, now what if n becomes 2000? 1 million. That's gonna give the equation now becomes n 1000 over 1 million. So we're going to have 1000 left. So this equation now will become 1 over 1000. That's very small. What if n is now 100? Remember, n goes from 0 to infinity. Okay, So what if n is equals to like 1 million, 10 million? So so 1 over 1000 is a very small number. Now let's do that division. That's gonna give us 0.001. What about 1 over 1 million? That is 0.001 for 1 over 1000. What about 1 over 1 million or 10 million? Let's see. Okay, that's very lot of zeros, decimal places. Very minute. So that's 0.000001. So it's becoming so insignificant. So as n increases, this term is converging towards 0. As n is getting bigger and bigger, this term is converging towards 0 and to evaluate to 0. So the overall here is 1 plus 0. So remember this one, this term here, n over n gave us 1. So we have now 1 plus 0, that gives us 1. So the whole of this term now is approaching 1 as n increasing. This one approaches 1 as n increasing. We saw that before. And then this one is also approaching 1 as n increasing. Now let's evaluate this one and see what happened there. So n, 1 over n to the power n, 1 over n to the power n, 1 over 3, sorry, 1 over 3 to the power n. That's gonna approach. That's gonna converge to 0 as n increasing, because when n is equal to 0, this one will be 1. Okay, when n is equal to 1, this one will equate to 1 over 3 to the power 1, which is 1 over 3, which is 1/3. That's getting smaller already from 1. The first one was 1 when n is equal to 0, but when n is equal to 1, it is 1/3. When n is equal to 2, now we start to multiply. It's going to be 1 over 3 squared, which is 1 over 9, which is even smaller than 1 over 3. Now what if n is equal to 1000? So we have to multiply this 1000 times. So this denominator is going to be very big. So the numerator doesn't change, it doesn't increase, it doesn't do anything, it doesn't reduce, it doesn't increase. But 1 times 1 is 1. 1 times 1 times 1, that is 3 times, is still 1. 1 times 1 times, it doesn't matter how many times you multiply 1 by itself, it's still going to boil down to 1. So so the numerator wouldn't change, but the denominator will skyrocket. All right, so that's gonna drive down the total value of this expression towards 0. Okay, so what we have now, we have here 0 here, we have here 1 plus 1 plus 0. All right, so the limit now, when this n approaches infinity, will be 1 plus 1, because this one evaluates to 0. So that's what we found here. So that's how you express it. The limit when n approaches infinity is equals to 2. 1 plus 1, 1 plus 1 is equals to 2. That's how we got to here. Okay. Okay, so this is question 2C. Question 2C is asking us to redraw this graph, these lines. So if you look at this one, the first one is g of x is there, and then we are asked to draw the g of x negative 2. That's just gonna drop down the curve 2 points along the y-axis. So the curve will now begin from here, 1, 2. So the graph will be here now. That's bad. That's terribly bad. something like that. Okay, that's the first one there, and then the second one we asked to evaluate that what g of x plus 3. Okay, that's different. See x plus, if you notice here, x plus 3, the constant there is added in the bracket. Okay, inside the bracket, that's telling us to move the curve along the y-axis. We move the curve along the y-axis how many times? Let's see, 3 times. So if we move along the y-axis axis towards the left 3 times, it's gonna give us, we move from here 3 times, it's gonna be 1, 2, 3. So the curve will be here now, something like that, and then that's where the curve will be now. Okay, so that was the solution for question 2 of the Living Cert 2023 paper 1 higher levels.